Section 5 of Chapter 6. Yay, we get to graph! Haha. Graphing square root and cube root functions. So what we're going to do is this. You have graphed parabolas, and if you'll remember, a parabola is a graph of an x that is squared. And what we're doing is we're graphing now a square root of an x, which, if you'll remember, is the inverse of an x squared. And an inverse, when you graph an inverse, what you're doing is you're reflecting it around this diagonal line that is x equals y. So, therefore, your function, the graph of the function of the square root of x looks like this half of a parabola. And we have to do just half, remember, to make sure that it is a function. Because if it were a whole parabola, then it would not be a function. So we have to set our domain, and in this case, the domain is x greater than 0 and y greater than 0, so it keeps it in quadrant 1. So you're going to need to kind of keep in mind and memorize what this kind of looks like. This is what a square root function looks like. And the reason for that is this was the parabola that went like this up, and what we've done is we've reflected this half around that diagonal line. So anyway, and if that didn't make sense to you, just trust me. This is what the square root function looks like. And if you want to put in some numbers and make sure and test me, that's a good idea too. The cube root function looks like this, because if you'll remember, a cube root had a bend in it so that one end went up and one end went down, and depending on if it was positive or negative, that would depend which direction it turned. So when it's positive, what we're going to do is we're going to reflect it around that axis. So now it's going to start, it's going to be up on the right and going to be down on the left if it's positive. So a cube root of x goes a little bit up on the right and down on the left, and that's what the parent function looks like, the graph looks like. So if you utilize that, then what we can do is pretty much we can get an idea of the shape it should be, and then we don't have to plot 82 points, all right? So here's what it's, and the domain and range both for a cube function is just all real numbers. It can go both directions. All right. Okay, so let's now see, well, what happens if we don't have just a square root of x? What if we mess around with it? And you know what happened with parabolas, and the same type of things is going to happen with the square root. So what we're going to do is, and in your assignment, it's going to say graph it and then compare it to the parent function. So that's what I'm going to do here to show you. So the square root of x, you know, is just I've drawn the parent function on this graph already. So now if we want -2 times the square root of x, I've chosen some strategic numbers so that I can get a square root and not have strange numbers in there. The strange numbers will work. They're just harder to graph. So 0, square root of 0 is 0, times -2 is 0. So that's where we're going to start. Square root of 1 is 1. 1 times -2 is -2. Square root of 4 is 2. And 2 times -2 is -4. So here's 3 points there. There's 0, 0. 1, -2 is going to be here. And 4, -4 is going to be here. So what we can, and then when we can see that, well, it's reflected over the x-axis. And if you'll remember, when we make something negative, it's going to reflect it somehow. So if you've got a square root function, if the function is negative, then it's going to reflect it over the x-axis, and it's going to go downward instead of upward. All right? And the 2, if you'll remember with your parabola, I think I did you a disservice because I said if you multiply by a whole number, remember it got narrower. But the reason it got narrower is because it was stretching it upward and downward. And so this square root is actually being stretched upward and downward by the power of 2. So as it's stretched upward, it's actually getting wider if you're looking at it sideways, but it's going to be stretched up and down, in this case downward. So that's what that function will look like now. So then it's going to, the problem is also going to ask you what is the domain and the range, and you can see that if it starts here and moves that way, the domain is going to be your x's. So the domain is going to be x's are all positive, so x greater than or equal to 0, and the range are all the y's, and you see that the y's are all negative. It's down below that x-axis. So the range is y is less than or equal to 0. So that's your domain and your range. Okay, so if you've got a square root, you're going to have like a half of a parabola, and it's going to either be stretched or shrunk, and then it's going to either be flipped or stay up on top. All right, let's do a cube root. So here's our parent cube root function. Ooh, not quite as pretty, but you get the idea. And it matches our parent function over here. And again, I've chosen some strategic numbers that are cube roots to make it easier for us to plot. So 0 is going to be 0, and cube root of 1 is 1, times 1/3 is 1/3. Cube root of 8 is 2, times 1/3 is 2/3, and -1, remember we can take a cube root of -1 is -1 times 1/3 is -1/3. So now we can plot these. 0, 0 is right here. 1, 1/3 is right there. And 8, 2/3. So it goes way over and it only goes up 2/3. And then what we can do is we know that it's going to be the same this direction, -1, -1/3, and the same thing with that 2/3. So what we've got here is just a very small bend. Ooh, with my lovely drawing, don't you know? Hopefully yours are nicer than mine. There we go. All right, so now when you compare, oh, and we also need to say that the domain and the range are both all real numbers. All right, so then what you're looking at is this. You've got the same general shape, the little bit of a bend. The reason it's less of a bend is because this multiplying by 1/3, it's being shrunk by 1/3. So up and downness, the vertical aspect is being squished. So that's why it doesn't have quite as much of a bend, and it's going to be a smaller bend. All right. So if you're multiplying by a whole number, then you're going to be stretching. If you're multiplying by a fraction, you're going to be shrinking, and that'll squish that bend. All right, let's, so if you need more of that, then make sure to get it written down. Let's move on. Let's do a word problem, because you know I love these, and it'll get us away from the graphing for just a little bit, give us a break from graphing. A pendulum's period, which is, a period is one swing, so from this side to that side is its period. And the period is modeled by t equals 1.11 times the square root of L, where L is the length of the pendulum. T stands for the length of the time of its period. All right, so here's what happens. I want to know, if the L is the length of the pendulum, how long is a pendulum with a 3-second period? Now, you've got a couple of options here. You can plug this into your graphing calculator and use the trace button to find where the T is 3 seconds. This problem is actually, in all honesty, I think it's easier just solving it algebraically. We can solve this. If you have a graphing calculator and you want to plug it in and use your graphing calculator and get some practice on that, by all means, you should do that. Go right ahead. What we're going to do is I'm going to show you how to solve it algebraically, because the T is the 3 seconds equals 1.11 square root of L, and L, I want to know how long is the pendulum. The L is what I'm looking for. So I'm going to divide both sides by 1.11, and I used my calculator already, and I found that that is roughly 2.7. And so now 2.7 is right about the square root of L. And so in order to solve this, I need to square my square root. And 2.7 squared is 7.3. So the length is roughly 7.3 feet. So for me, this was actually easier to solve it than to plug all of those numbers into the calculator. And then, but what you can do is, if you were to plug it into your calculator, you're going to have a square root graph that looks something like this. And so you would trace along until you got to the 3, and that would be at 7.3. All right. Okay. Next is this. So you know that we're not going to always just have, here's your square root or here's your cube root. We might have more added to it. So when we do that, we're going to go back to our h and our k that you'll remember from when we did parabolas. So we might have a number, and we did this with the -2 times the square root. So this is our a. This is if we're shrinking or stretching, and if we're flipping. That's going to be determined by the a. If we're going to shift that, now if you'll notice, you'll remember from your, hopefully you've got it written down in your notes, both of the other two graphs started at the origin. Both of these are going to shift that origin, or not the origin itself, but they're going to shift our vertex, or where we begin our graph. And the h is the horizontal shift, so if we're going to go right and left, and the k is the vertical shift. Now you've got to remember that the h is negative, so the h is going to be the opposite of what it looks like in the equation. The k is going to be the same. So here's what we're going to do. Let me give you one. I don't know if I can have both of this up at the same time. We'll try to have part of it anyway. So here's our function. The function of x is 3 times the square root of x plus 2 minus 4. And what I've put on here is the parent graph, just so that we can see, okay, where did we start? And now let's put another one on. So what we're going to do is this. We know this is a square root function, so it's going to look like this. We know that it's going to shift, because this is a positive 2 and we want the opposite, it's going to shift to the left 2, and our vertical shift is -4. So 1, 2, 3, 4. So here is where we're going to start our graph. All right, and then if it didn't have the a, then we would just move this over here and have the exact same graph. But in this case, because we're multiplying by 3, remember it's going to stretch it. So it's going to be wider. And so what I've done is I put in x is 2. Oh, and you can't see with that marker. Here we go. If x is 2, then 2 plus 2 is 4. Square root of 4 is 2. 2 times 3 is 6. And then 6 minus 4 is also 2. So if you put in 2 for x, you're going to get out 2 for y. So let's find that. 2 for x, 2 for y. There's our second point. So this is a very stretched graph. So this is going to look something like that. So there's our new graph. Okay? And find a place to start. Find one more point, and then just estimate your turn, your arc from there. You do need to determine, though, the domain and the range. The domain in this case, the x's, are going to be anything that is to the right of -2. So x greater than or equal to -2. And the range is going to be anything greater than -4. So y is greater than or equal to -4. All right? So make sure that you set the domain and range on those. Okay? I've got one more. I only have one graph, but here's what we'll do. So the last one I want to let you do one that is a cube root, so that you've got that in your notes. X minus 2 plus 3. Okay, so now while you write that down, I'm going to erase this loveliness. Okay, and if you'll remember your parent graph, so you don't always have to put that in there, but you need to at least have it in your mind. So the parent graph, remember, of a cube goes this way and then goes that way. And the bumps on my graph make it kind of jittery, but that's okay. All right, so this is what we're starting with. This is the parent graph. You can look at your h and your k. So the h is -2, which means we're going to go to the right 2, because remember, it's the opposite of what it says. It says -2, so we're going to go to the right 2. So 1, 2 this way, and we're going to go up 3 because of this The K value is 3. So 1, 2, 3. So here is, that's your turning point. All right, that's going to be the vertex. So the turning point is there. So we're going to do some arcing this way and some arcing this way, except that because looking at our A value is -1. So we're not going to stretch or shrink, but we're going to do the opposite. So we're going to reflect it, or we're going to flip it. So what you're going to do is you can put in a value. Let's put in, what did I choose? I chose x equals 3. Let's do it with a different marker so you can see it. All right, let's choose x equals 3. And when we do that, the reason I've chosen that is because 3 minus 2 is 1. And the cube root of 1 is 1. So I have -1 plus 3, which is 2. So we have the point 3, 2 is on our graph. So we're going to go to 1, 2, 3, 1, 2. And then we're going to have it's going to swing that direction. And then our other half of our graph, because if you see that we flipped it, so to the right of my turning point goes down instead of up. And so to the left, it went down before, so now it's going to go up at the same angle that it went down. So there's my new graph. And you do have to say the domain and range. And in this case, you can see that it's just any number. So all real numbers is your domain and your range. So here we go. You can do this. It's not the easiest section ever, but you can do this. Make sure that you have these in your notes, these equations, so that you remember your H and your K, and make sure that you have the parent graph. Once you start recognizing that parent graph and start understanding what the different parts and pieces of the function do to that graph, it'll start becoming easy and you won't have to pick as many X's to pick points on there. All right, good luck. See you soon.